Sample problem 18.3. For each process, determine the sign of delta S for the system. A, decomposition of calcium carbonate to give CaO and CO2. B, heating bromine vapor from 45 to 80 degrees Celsius. C, condensation of water vapor on a cold surface. D, reaction of ammonia and HCl gases to give NH4Cl solid, and then E, a dissolution of sugar and water. So we're not calculating them, we're just qualitatively determining whether the entropy changes upward or downward. Does it increase or decrease? If it's an increase, that would be a positive change. If it decreases, that would be a negative change. So the first one is calcium carbonate, giving you calcium oxide plus CO2. Okay, this was actually a relatively simple one. Here we think about it this way. You have 1 mole of a solid, which is going to have a certain amount of entropy. And then you're going to form a mole of another solid, which, although they won't have exactly the same amount, they're going to be pretty close to each other. 1 mole of a solid to form 1 mole of a solid, those entropy values are going to be relatively close to each other. But we're also forming a mole of a gas. Okay? So what happens is gases, because they can occupy large volumes, they have a large degree of freedom. They have large entropy values. The entropy of a gas, let's say we have 1 mole, is much greater than the entropy of a liquid. In fact, I'll write it this way. Much greater than, which is greater than the entropy of a solid. So if you have a mole of a solid forming a mole of a solid, they pretty much counteract each other in terms of the amount of entropy they have. But forming a mole of a gas is going to be a large amount of entropy. So this is an increase. So we would say the sign change for delta S is positive. Or we could write it this way, delta S is greater than 0. Let's take a look at B. In B, we're heating bromine vapor. Remember, bromine is diatomic, right? So diatomic substances are bromine, chlorine, the halogens, fluorine, chlorine, bromine, iodine, but then oxygen, nitrogen, and hydrogen. So we're changing this. It's going to still be bromine vapor, still bromine gas, but we're starting at a lower temperature and we're going up to a higher temperature. In general, what happens is as you increase the temperature of a substance, the degrees of freedom increase. So low temperature, the gas molecules are moving at certain speeds on average. But at high temperature, so this is temperature, they're moving faster. So I'm going to draw the vectors representing their motions longer. Okay, so higher temperature, higher entropy. Lower temperature, lower entropy. Okay? So that means if we're going from a state of lower entropy to one of higher entropy, again, that's an increase. So entropy is going to be greater than 0. The entropy change is going to be greater than 0. Let's take part C here. In part C, condensation of water vapor. So water as a gas is condensing into water on a cold surface. So we don't know, it could be a liquid or a solid. Let's just say it's a liquid. The answer would be the same. Gases have high entropy values. Liquids have lower entropy values. So you're going from high entropy to lower entropy, so that would be a decrease. So delta S would be negative, or delta S would be less than 0. Okay? In part D, we're looking at ammonia vapor and hydrogen chloride vapor forming solid ammonium chloride. Okay, so here you have a mole of a gas, you have another mole of a gas, so you really have 2 moles of a gas forming 1 mole of a solid. So generally, the fewer moles you have, the less entropy you have. And going from a gas to a solid is a reduction of entropy. Solids have less entropy than gases. So this one, again, is negative. Negative, or delta S is less than 0. It's a decrease in entropy. Okay? So there's the first 4. We've got one more, so let's make a little room up here. And this one is dissolving sugar into water. So sugar is a solid, and we're going to put it into water and make it aqueous. Okay, aqueous. Aqueous means distributed, right? The large pieces of sugar, which have pretty low entropy. Solids have lower entropy. But now it's going to be dissolved into water, so it's going to be more randomly distributed. This is a higher entropy. Okay, the more randomly distributed things are, the greater their entropy values, their standard entropy values. So delta S, again, would be positive or greater than 0. Increase in entropy going from undissolved to dissolved.